Okay, this is working on the answers for the 2C and D practice. So the first page here, 1 through 4, is 2C. So let's dive into it. So the first step is to find the vertex. So it's left 1 and down 2. So from 0, 0, we're going to go left 1, down 2, put a point. Second step is to look at the slope, or dilation. And let's treat it as slope. So it's negative 3 over 1. So we're going to go rise over run. So rise, meaning up or down, up or down. So now we got to go down 3 and to the right 1 and down 3 and left 1. We can continue with that pattern forever. And then connect your dots, make your V. And there's your absolute value function with the dilation. Number 2, again, let's look at, so we got right 2 and up 5. So from 0, 0, that's our original from our parent function. We go right 2, up 5. That's your vertex. That's the maximum or minimum of the graph. Now we got to look at the fraction, negative 1/3. And notice when I say negative 1/3, I'm putting the negative on the 1. So it's negative 1, so that means you're going down 1 and then to the right or left 3. So down 1, right 3, down 1, left 3. You can continue with that pattern forever. 1, 2, 3, and keep going. And over here, it's off the graph, but you could keep going if you want, and there's your graph. So a fraction less than 1, the absolute value of less than 1 for the dilation makes it wider. And look at here, this negative 3, the absolute value is greater than 1, so it makes it a narrower V. All right, moving on. Number 3, we need to, first I would say find the vertex. So here we go. The vertex is so it's left 2, and it's down 4. So where would you put that on this equation? Now, I don't care if you fill in the blanks, the boxes, or you write your own equation. On the outside here would be a down 4, and left 2 means x plus 2. And then we need to figure out the dilation. So we go find your next coordinates. It doesn't matter which one you would find. We'd go up 1, 2, 3, and to the right 1. So that'd be a rise of 3 over 1, which is 3. So we put a 3 on the outside. Like I said before, if the boxes confuse you, just write your own function. And that's good. All right, next one. Find the function of the graph. So we have the vertex is up 1 from 0, 0. Our next coordinates, so up 1 would be on the outside, plus 1. X, there's no left or right, so you could say plus 0 or just x. So you actually don't even need that there. And find your next coordinates. Doesn't matter which one you look at. You're going down 1 and 1, 2, 3, 4 to the right. So down 1 and 4 to the right. So your scale factor or your dilation is negative 1/4. So again, you can write it as a fraction. We don't need the x plus 0 because plus 0 is just x. So that's all you really need. All right, moving on to the next page. Now we're introducing inequalities. So it's doing a lot of the same stuff, except now you're going to shade. So we have left 3, down 2. So left 3, down 2. Let me zoom this in a little bit more. There's no scale factor on the outside. Sweet. So that means our function is just right 1, up 1, right 1, up 1. And those are going to be our other coordinates. You can keep going in that pattern, right 1, up 1. And you can just keep going if you want. Now, the next thing is look at Is it dashed or a solid line? Well, because it's equal to, anytime it's equal to, it's a solid line you're going to draw. So over here, look at here, equal to, solid line, equal to, solid line. So anytime you have an equal to, you're going to draw a solid line. If it's not equal to, you do a dashed line. Now the next thing would be how we shade. So this is where the less than or greater than symbol come in. If it's less than, you shade below the graph. So below the line, below the V. So where's below? Oh, here's somewhere the bottom. So you can shade all around. Cool. And there's your graph. Next one. We have, looks like up 3, no left or right. From 0, 0. Looks like now we have a scale factor of 2 over 1. So our next points are going to be up 2, right 1, up 2, right 1, up 2, right 1, left 2, or up 2, left 1, up 2, left 1, up 2, left 1. And now it's dashed line. Let's do that in the same color. It's a dashed line because it's not equal to, so that's how we tell if it's equal to or not, by looking at the graph. And now it's a less than symbol, so we shade underneath the graph. So unfortunately I had another one here that shades underneath. But here you see, so if I were to ask any point along that dashed line, it is not equal. The left side would not equal the right side. So I'm just going to pick a point here. So if I pick the point, say 2, 7, that is on the dashed line. So on 2, 7, that'd be the x is 2, the y is 7. So if you substitute that in, it has to work if it's actually a solution. So 7 is less than 2 times the absolute value of 2 is 4. And so this is saying 7 is less than 7, which does not make sense. No. So that tells you it's not a solution. There are infinite amount of solutions anywhere in the shaded area. It just means there's an infinite amount of coordinates that would work. Any point in there, any coordinate. All right, graph the next one. We have left 1, up 3. We have a scale factor of 1 over 2, so we go up 1, over to the right 2, up 1, left 2, and we can continue. I would highly advise continuing to just keep going, and up 1, right 2, up 1, right 2, up 1, right 2, and then it's equal to, so it's a solid line. And now we have something a little different. Greater than symbol. Greater than, you would think, shade above. We do. Shade above. Shade above the V, so inside of the V in this case. But above the line. Anywhere in the shaded area is the solution, or in this case, on the actual V, because it's equal to. All right, give the inequality for the given graph. All right, so now we need to figure out the vertex, which is right 2 and up 3 from 0, 0. So up 3 is plus 3, so we put that on the outside. Right 2 is minus 2. And then is there so I'm picking points. And we look up 1, right 1. So 1 over 1. 1 over 1 is 1. So we can put a positive 1 out here. But that really doesn't do anything. So you really don't need it there. And then we need to know shading. Or first it's dashed, so it's not equal to. And then is it greater than or less than? Well, it's shaded underneath, so it is less than. So let me rewrite this. So f of x is less than or equal, no, not equal to, less than 1, you can write the 1 if you want. You don't need to. X minus 2, because 1 times anything is just whatever that is. So 1 times the absolute value is the absolute value. And that would be the graph. All right, that should be it. Please comment.